Welcome back, everyone. We are now going to move on to the second video for Chapter 4, where we're going to talk about predicting solubility. When an ionic compound dissolves in water, the positive and negative ions become separated from each other by the water molecules. This is called dissociation or ionization. We talked about this in the last video, so I just want to review it real quick before we start talking about solubility. So here we have our sodium chloride solid. When it dissolves in water, it forms the sodium ion and the chlorine ion. That's because the water molecules are able to get in between the sodium and chlorine and kind of pull them apart and dissociate them from the compound. In general, when ions are in solution and they react with each other, there's only a few things that can happen. First, two of the ions can form a solid that is insoluble in water. This is called a precipitate. Or you can have a gas form. You could also have an acid that neutralizes a base. Or you can have one of the ions oxidize another. So those are the four types of reactions that can occur when you have aqueous solutions mixed together in a reaction. 2, 3, and 4 we'll talk about a little later on. Right now, when we're talking about solubility, we're going to focus on number 1. So how can we predict when an insoluble solid will form? First of all, let's talk about precipitation reactions. A precipitation reaction is one in which a solid product will form. One of the products will not be soluble in water. It will be insoluble. The reason that they're insoluble is because the water molecules cannot overcome that attraction between those ions. So the ions are held together so tightly that the water can't come in and dissociate them. Here's a list of common solubility rules. This is a qualitative approach of understanding what compounds will dissolve in water and which ones won't. This is found in your book, so you can access this at any time. Later on in the year, we'll talk about specific numbers when it comes to solubility, how much actually dissolves. We'll talk about that later. Right now, we just want to know if we can identify the solids formed and which compounds will remain in an aqueous form. So on this table, the top half, you're looking at, on the left side, soluble ionic compounds with those anions. And then on the right is important exceptions. So those exceptions will create insoluble compounds. If you notice the first two, nitrate and acetate ions, they have no exceptions. They will always be soluble in water. But if you look at the last four in that top box, you will see that chlorine, bromine, iodine, and sulfate are generally soluble, except if they are bonded to those specific ions listed in the right column. So if we had silver bromide, it would not be soluble in water. It's important for you to know the exceptions because that's going to indicate which ones are insoluble. The bottom half of the table on the left side shows you the insoluble compounds. So compounds that have those four anions in them will generally be insoluble. There are exceptions. If you look on the right, if you have carbonate ion that is bonded to an ammonium ion, that will be soluble. If you look at the exceptions, you'll notice that ammonium is an exception to all of them. Then you also have the alkali metal cations, so lithium, sodium, potassium. If any of those are bonded to sulfide, carbonate, phosphate, hydroxide, they will be soluble. And then you also have some alkaline earth metals in there too, like calcium, strontium, barium, that will be exceptions depending on the anion that it's bonded to. So it's very important that you are able to read this table, but it's also very important that you have it memorized. You need to be able to know what will bond with what to determine whether or not the product will be a solid or if it will remain in aqueous form. It's going to be extremely important for later on in the video. So make sure that you have your book out and you have page 125 open and looking at table 4.1 as we go through the video. Let's do some examples. So classify each of the following as either soluble or insoluble in water. So first we have sodium carbonate, and then we have lead sulfate. So the first thing you want to do is look at sodium carbonate. Look on the chart. Look for the carbonate ion. You'll notice that it's on the bottom half of that table. The carbonate ion is generally insoluble, except if it's bonded to alkali metals. Well, alkali metals include sodium, so sodium carbonate is soluble in water. Now we have lead sulfate, lead 2 sulfate to be exact. Lead sulfate, if you look at the sulfate ion in the top half of that table, you will notice that it's generally soluble, except if it's bonded to lead 2. So this lead 2 sulfate is insoluble in water. That's why it's so important to be able to memorize these rules so that you can easily identify soluble and insoluble. I have the next two slides here will cover predicting solubility of the different compounds, whether they're going to be insoluble or soluble in water. So what I'd like to do on this slide, I would like you to pause this slide, look through all the compounds, and determine which ones are insoluble in water. So go ahead and pause your movie now. We'll review it when we come back. All right, welcome back. Hopefully you've gone through every single one and you've been able to identify the ones that are insoluble in water. So the first thing we're going to look at is nickel 2 sulfide is insoluble. That sulfide ion is not soluble when it is bonded to nickel. Barium sulfate is an exception. Sulfate generally will dissolve, but when it's attached to barium, it is insoluble. Lead 2 chloride is also insoluble in water, as well as magnesium hydroxide. They will not dissolve in water. So hopefully you were able to use your solubility guidelines to identify these 4 compounds as insoluble. Now on this slide, what I would like you to do is pause your video again, look over all of these compounds, and determine which ones are soluble in water. So go ahead and pause your video now, and we'll review them when we come back. All right, welcome back. I hope you were able to look at all the compounds and decide which ones you believe are soluble based on your solubility rules. So let's take a look. Ammonium carbonate, soluble in water. So is hydrochloric acid. You should have gotten copper 2 nitrate as a soluble compound, and calcium nitrate. Barium nitrate is also soluble, along with ammonium nitrate. Barium chloride is also soluble in water, and so is nickel 2 nitrate. I hope you were able to go through, look at your solubility rules, and identify the soluble compounds in this slide. So will it precipitate form? When we're looking at predicting products, can we determine if anything in the product side, will it be a solid? So to do this, the first thing you need to do is determine the reaction type. Are you looking at a single replacement, a double replacement? Note the ions that are present in the reactant. So do you have a potassium? Do you have a nitrate? Consider how these ions in the reactant side will rearrange to form your product. So what combination of cations and anions will be produced? Then use your solubility rules to determine if any product is insoluble. So that's why it's important to have these rules memorized. So let's take a look. What will happen when the following reactants are mixed together in water? So we have potassium iodine and we have lead 2 nitrate. If you take a look, potassium will be +1, iodine will be -1. You'll have lead 2, which is a +2, and you'll have nitrate, which is a -1. If you notice that you are dealing with 2 ionic compounds, it means that it is a double replacement. So they're going to switch partners or switch who they're bonded to. So we're going to form potassium nitrate and lead 2 iodide. Once you have your products formed and you've balanced your equation, take a look at your solubility guidelines. Are either one of the 2 of the products going to be solids when mixed together or when they're formed? Yes, the lead 2 iodine is insoluble based on your solubility rules. In this slide, I would like you to pause the video, go through predict your products, balance your equations, and then based on your solubility rules, determine if any of your products will be solids. So go ahead and pause your video now, and we will go ahead and review them once you come back. All right, welcome back. We have 3 equations here. I can tell you in each of these equations there will be a solid product. So go through, separate your ions in your reactant in the reactant side, and go ahead and rearrange them to get your products. So I hope that your products look like this. Balance your equations. Now, using solubility guidelines, you should be able to indicate, or you should have been able to choose, that H2CO3 is insoluble, calcium carbonate is insoluble, and so is iron 2 hydroxide. These will all be in solid form when you mix the aqueous solutions together. So make sure you check your solubility guides for anything that will be in solid form as a product. So it's very important that you know your solubility rules. Make sure you memorize them, practice with them. One thing I really want to quickly review is exchange reactions. They're the same thing as double replacement. It's just a fancy name. These are the reactions where the positive ions and the negative ions will exchange partners. So here's an example. You have silver nitrate reacting with calcium chloride. The silver will go and bond with the chlorine. The potassium will bond with the nitrate, switching partners. And we get 2 new substances. Out of those 2 substances, if you check your solubility rules, you will notice that silver chloride will not dissolve in water. It is insoluble. All right, that is the end of the second video. The last video for this section of chapter 4, we will cover net ionic equations. You're going to need to know your solubility rules, so I hope you've studied up.